All right, we're looking at the Unit 2, Lessons 4, 8, and 9 practice quiz. First question says we need to factor completely, and if the polynomial is not factorable, we're going to write prime. So for number 1, we have 3s t squared minus 9s cubed t plus 6s squared t squared. And for this problem, I see that there's 3 terms, so I'm going to look and see if there is anything in common between the 3 terms. I can see from the numbers that each number has a factor of 3, so I can take that out. There's an s in each term, so I take that out, and there's a t in each term, and I take that out. And I'm only taking the first power out when I factor because for s's, there's only one factor here, so the other terms have more than one factor, but this only has one factor. So I'm not able to take more than one factor out. And so when I take that out, from this first term, the only thing that's left over is a t minus, and then from the second term, if I take 9 and I divide out 3, I'm left with 3, and there's 2 more factors of s that I need, plus a 2, because 3 times 2 gives you 6. I took one of the s's and one of the t's out, and there's another s and t left. For question 2, we've got 6x squared plus 7x minus 3. And for this one, if I look for a GCF, I'm not going to be able to find anything, so I'm just doing basic factoring. Doing a times c, 6 times negative 3 is negative 18. So I'm looking for 2 numbers that multiply to negative 18 that add to positive 7. Those numbers are 9 and negative 2. So I'm going to be splitting up the 7x into 9x minus 2x. You're going to do that whenever the a value is not 1. So once you split that up, you have 4 terms, and then you're going to group them by 2 terms. The first 2 terms have a 3x in common, and you're left with 2x plus 3. The second 2 terms are also going to have a 2x plus 3 that's left over. So we want to figure out what number times 2x gives me negative 2x, and that number is negative 1. So my first factor is 2x plus 3, and my second factor is 3x minus 1. For question 3, we're going to try to write this in quadratic form. Quadratic form is basically just the ax squared plus bx plus c, the key here being that the power of the variable in the first term is twice as big as the power in the second term. So when we look at this problem, we see we have 8th power and the 4th power, and 8 is obviously twice as big as 4. So we need to be able to write this as something to the second power in the first term, and then just the something in the second term. So the something is just whatever you have in this term, c to the 4th. And so you're going to put c to the 4th over here, c to the 4th to the second. Based on one of our exponent properties, we're going to be multiplying these powers. 4 times 2 is 8. So this is the quadratic form of the original expression. For question 4, we're simplifying. We've got a trinomial over a binomial. Our trinomial on top is something that needs to be factored, similar to question 2. I did that down here. My a times c is negative 30. 2 numbers that multiply to negative 30 that add to negative 1, our b value, are negative 6 and 5. So I'm splitting up the middle term again. The first 2 terms, grouping, they have in common 2k. We're left with a k minus 3. The second factors will also have a k minus 3, and we need to multiply by 5. 5 times k is 5k. 5 times negative 3 is negative 15. So my first factor is k minus 3, and my second one is the 2k plus 5. So my numerator is those 2 terms multiplied together. My denominator with those 2 terms is a difference of squares. It's k plus 3 times k minus 3, so I'm writing that out. I see that each the numerator and the denominator has a k minus 3, so I cancel them out, and I'm left with 2k plus 5 over k plus 3, and that's my final answer. For question 5, we have 2 fractions that are multiplied together, and I see a plus y and y plus a, and those are identical things, so I can cancel them out, and I'm left with 4 over 6, and 4 over 6 reduces to 2/3, and that's our answer. For question 6, we have a fraction divided by a fraction. So the first thing I did is I flipped over the second fraction. When you flip the second fraction over, the division becomes multiplication. And then I factored each of the expressions. So this is my factorization. I noticed that there was an x plus 2 that I could cancel with x plus 2 over here, and x plus 3 up here that I could cancel with x plus 3 down here. 3 times 4 is 12, divided by 6x times x minus 3. 12 over 6 is 2, so there's a 2 on top, and the x times x minus 3 is on the bottom.
Straight.
Okay, for question 7, it says that we have a right triangle. I'm going to slide this over a little bit. With an area of x squared minus 4 square units, has a leg that measures 2x plus 4 units. We need to determine the length of the other leg of the triangle. So for this problem, you need to know the area formula for a triangle is 1/2 base times height. And then you're going to plug in the values they gave you. The area is x squared minus 4. One of the sides of the triangle, either the base or the height, it doesn't matter, is the 2x plus 4. And then the other side is unknown. So we're going to try to get the unknown by itself. So the first thing I did is I took half of 2x and I got x, and I took half of 4 and I got 2. And then I divided each side by x plus 2, and I ended up with this equation right here. So my goal is I need to simplify this expression. So I'm going to factor x squared minus 4, and that factors into x plus 2 times x minus 2, and then I can cancel the x plus 2's out, and I'm left with just x minus 2, and so the length of the other leg of the triangle is x minus 2 units. For question 8, we're doing least common multiple, and this is actually one of the homework questions from the lesson 9 homework. We've got 3 things. Our first thing is 2r plus 2, and then we have r squared plus r, and then r plus 1. And this is the way you factor each of those 3 things. So our least common multiple, we need a 2, we need an r, and we need an r plus 1. Multiply it all together, and that's your LCM. For question 9, simplifying each expression, we have 2 different fractions that we're adding together. In order to add them, you need a common denominator. The common denominator is found by finding the least common multiple of the denominators. So breaking down the 6, c squared d, 6 is 2 times 3, and then we have c squared and d. 4 is 2 squared times c times d cubed. So in our least common multiple, the higher factor of 2, we need 2 of them. We need a 3. We need 2 of the c's, and we need 3 of the d's. So our common denominator is 12 c squared d cubed, because 2 squared is 4, 4 times 3 is 12. So I write each of these denominators, and then I write my original numerators 1 and 3, and then I'm looking for the missing stuff. So this first denominator is missing a factor of 2. 6 times 2 gives me 12. And there's 3 factors of d, and it only has 1, so I need 2 more factors of d. The second fraction, 4 times 3, would give me 12, so I need a 3. And I have 1 factor of c, but I need 2, so I need another c. And then you're just going to multiply the numerators and combine the 2 fractions into a single fraction. 1 times 2d squared is just 2d squared, and 3 times 3c is 9c. So adding that together, you get this answer. Question 10 is pretty much the same kind of process, except we're doing subtraction of 2 fractions. We need to find the common denominator again. So we're going to find the least common multiple of our denominators. Our first denominator is 2x minus 12, and that factors into 2 times x minus 6. The second one, x squared minus 4x minus 12. We're going to find AC, that's negative 12, and 2 numbers that multiply to negative 12 that add to negative 4 are negative 6 and 2. So my 2 factors are x minus 6 and x plus 2. So that means that my least common multiple, I need a 2, I need an x minus 6, and I need an x plus 2. Rewriting that common denominator for each of my fractions. Writing the original numerator, 5 and 20, and then leaving some space for the leftover stuff, or what was missing. The first denominator was missing the x plus 2, so we need to multiply by x plus 2 on top. The second fraction is just missing the 2, so we're going to multiply the 20 by 2. And then we have to distribute on this numerator. 5 times x plus 2 is 5x plus 10. 20 times 2 is 40. 10 minus 40 is negative 30. So I see on the top 5x minus 30, I can factor a 5 out, and that's going to leave me with x minus 6. and then I have an x minus 6 on the top and bottom that I can cancel out. And my final answer is 5 over 2 times x plus 2. For question 11, it says the expressions 5x over 2, 20 over x plus 4, and 10 over x minus 4 represent the lengths of the sides of a triangle, and we're going to write a simplified expression for the perimeter of the triangle. So the key here, I drew a triangle, I labeled all the sides. Perimeter is the sum of the 3 sides. So I found my common multiple, multiplying my 3 denominators together because they don't have anything in common, is 2 times x plus 4 times x minus 4. So I'm doing 3 fractions with each one of them has that same denominator. The first fraction, 5x, what was it missing? It was missing the x plus 4 and the x minus 4. So I need to bring them in on the top. The second fraction is missing the 2 and the x minus 4, so I brought them in on the top, times the original numerator 20. And the third fraction was missing the 2 and the x plus 4, so if I multiply all that stuff times the 10, once I multiply together and distribute, the first one is going to be 5x times x squared minus 16. The second one is going to be, I did 20 times 2 and got 40, so 40 times x minus 4. And then the third one I did 2 times 10, got 20 times x plus 4. Then you're going to multiply that stuff out and you will get all of these terms. You're going to combine your like terms. So we have negative 80x and positive 40x, positive 20x simplifies to negative 20x, and then negative 160 and 80 combines to negative 80. So I have a pretty much simplified fraction right now, but I did notice that each of these terms in the numerator is divisible by 5, so I took the 5 out, and I was left with x cubed minus 4x minus 16, and it's over this common denominator that we found, and that's your final answer.